Hi everyone, this is Dr. J. Nithya, Professor in the Department of Information Technology at K.S. Ranasamy College of Technology. The topic for discussion is interrupts in processes under the subject Computer Organization and Architecture. So what is an interrupt? When an interrupt will arise? So we can say that the interrupt are generated by an I/O device which can alert the processor when it becomes ready. So the processor is the one which is doing an important task. Whenever the I/O device, that is input-output device, wants to transfer any data, they will send alerting the processor by means of an request. That request is called as an interrupt request. So that request can be acknowledged or accepted by the processor only when the processor is free. So if the processor is ready to accept the data, it can give a signal called as interrupt acknowledged. So based on the interrupt received, the processor can perform a program. That program is called as an interrupt service routine. So where your processor has to come back. So the processor will move on to the interrupt service routine and it has to come back to the main program. So where your program has to come back, that will be stored in either some general purpose register or in the stack available in your processor. So this is sequence. So here it denotes a normal programming routine from 1 to m. So assume that at the stage of I an interrupt occurs. Whenever an interrupt occurs, the program has to be stopped and then the control has to be automatically transferred to the interrupt service routine. So this is a program for display routine. So the control will be transferred to the service routine. The processor will start executing this interrupt service routine and then it has to come back to the main program. So this is a normal sequence of steps which happens whenever an interrupt occurs. To do this processing, we are having some registers associated with the interrupt. First one, if you say interrupt latency, so what interrupt latency denotes? The time delay which happens between an interrupt is occurred and then the time it takes to service it. So the delay between request and the service of an interrupt is called as an interrupt latency. So the processor, while it's servicing the interrupt, it will save the contents of program counter and program status register, and then there are maybe cases where the same set of instructions may be used. So if you are using the same set of instructions, use a duplicate set of registers. That duplicate set of registers are called as shadow registers. So how you can enable or disable interrupts? Okay, that is sometimes the processor may be busy with some other task. You don't want the processor to be disturbed. In that case, the interrupts can be disabled. So there are different ways of enabling or disabling the interrupts. So for that purpose, a particular flag is available. That flag is called as interrupt enable flag. So this is the one which can be used to accept or disable interrupts. So when that value is equal to 1, the processor is making the I/O devices to accept the interrupts, and then if it is 0, the process simply ignores all the interrupt requests from the I/O device. What are the sequence of the events which happens when an interrupt is occurred? So whenever any I/O device interrupt a processor, what it will do? First one, the device may give an interrupt request. If it is enabled by the processor already, the processor will accept the corresponding interrupt and it will start the next program counter value, because after executing the interrupt service routine, it has to come back to the main program. That interrupt service routine has to be included. Then correspondingly, the contents of the program counter and status register has to be stored in the stack. Then it should not allow any further interrupts. So interrupt enable bit has to be correspondingly set as 0. Whatever request given corresponding to that, the service routine which is stored in a vector table. A table is there where your address of the interrupts are stored. That can be accessed and then it deactivates the corresponding interrupts. So whenever a particular interrupt is accepted and it starts being serviced, that particular interrupt has to be deactivated. Once it has completed the service, it has to get back all your program counter and your program status register contents from the stack back again, and it will resume back your main program. So how does this is a case where you have only one single device. But how does a processor handle multiple devices? So you will not be connecting only one device to a processor. You will be connecting multiple devices. Suppose if a processor is connected with multiple devices, how does the processor identifies which particular device is handling an interrupt, that is raising an interrupt? So that is done by means of a flag called as IRQ flag, which is there available in a status register of an interrupt controller. So what the processor will do is, it will be keep on polling the bits. So let us say I have 5 I/O devices. 5 IRQ bits are available. The processor will keep on polling the 5 bits. So it will check whether which particular bit is set. Whichever bit is set, then it denotes corresponding to that flag, whichever device is connected, that has raised a request. So this is the way the processor will identify the device from the multiple devices. Okay. here the next point, if you are handling multiple devices, if one request is being serviced, whether the process will allow the next request. So there comes a solution. So you have to set a concept called as priority. Okay, let us suppose I have 5 devices. Out of the 5 devices, I may set a priority to the device number 3. Okay, so if device number 3 and device number 1 are giving a request at the same time, based on the priority you have set, though they have given the request at the same time, the priority will be given only to the interrupt request number 3. Okay. Now, the second scenario. Let us say interrupt number 3 is having priority and interrupt number 5 is given more priority than 3. Consider this scenario when you will get the request 3 and 5 at the same time. So if you get 3 and 5 at the same time, the 3 is being serviced. Let us assume the case that the interrupt 3 is being serviced. If a request number 5 comes, since it is having higher priority than 3, the interrupt which is being serviced, that is number 3, is currently stopped, and the process will go to the interrupt number 5, start servicing that interrupt, and then only it will come back to the interrupt 3. So here you will have a priorities of interrupts. Then starting address of the bit. How does a processor identify? I have multiple devices. How does a processor identify which particular program to be executed for which particular request? So for that, a table is available which is called as interrupt vector table. It is like a normal table you have where you have the interrupt request number and the corresponding address. So corresponding, let us assume the same example. I have 5 devices. For each device, what is the starting address of the program for that interrupt service routine? So whenever that request has to be serviced, where is the program for that service? That address will be stored in the interrupt vector table. So whenever interrupt is coming, based on the priority, it is serviced and it will refer the interrupt vector table, and correspondingly that particular interrupt is being serviced. So after it will be executing that interrupt vector routine, then it will come back to the original program as usual. Okay, that's all the process sequence of steps which happens whenever interrupt is serviced. Thanks for watching. Happy learning.